Hello, grade 7 mathematicians, to my tutees. Welcome to this video lesson. So in this video lesson, we are going to appreciate a very beautiful math called remainder theorem. So when is this remainder theorem very useful? So let's apply it to this book exercise, to this problem. It says here, if the polynomials x cubed, positive x squared, positive kx, positive 1, and the polynomial x squared, positive 4x, negative k, have the same remainder when they are divided by x plus 2, so find the value of k. So as we can see, obviously we have a keyword, remainder. So it makes sense to make use of the remainder theorem. So what does the remainder theorem say? So the remainder theorem is applicable when we are dividing polynomials, wherein in the numerator we have a polynomial like 4 terms, 3 terms, okay? And it is divided by a binomial. So the denominator is a binomial. It has 2 terms. So again, the remainder theorem is applicable when the divisor has 2 terms. The first term is a linear term. It could be any letter, or in this example, our variable is x. And the second term is a constant term. Okay. So what can we get from the remainder theorem, or what's the story? How is it being derived? So, based from as an output to my study, okay, we can assume that the divisor here is a factor of this polynomial. Meaning, if we're gonna divide this polynomial by this polynomial, the remainder is 0. We can get the other factor. Okay? So, we are assuming that the divisor is a factor. And to do that, in order for the divisor to be a factor, this expression here should be equal to 0. Okay, in order to get the root of the x. Anyway, that can be a little abstract for now, but we would be able to appreciate factoring or finding the roots on some other video lessons. Okay, so again, when we say a root, it is a number which is a value of x, wherein if we substitute that root, okay, we are going to get a value of 0. Okay, in order for the x to be a root. Alright, so because a root is a point along the x-axis. Okay, so this is also a very beautiful math there. Okay, so if a value of x is a root, then the value of y is 0. That's why we equate this factor with 0. Okay, and then we isolate x, so we transpose negative a to the right side, since it will pass by a negative sign, then the negative a will be a positive a. Okay, so basically, to find the value of a, we are just going to negate the constant, or in other words, change the sign of the constant. So in this problem, our divisor is x plus 2 and we assume it as a factor. Then our x, our possible root, is negative 2. So our constant is positive 2. So negate positive 2, change the sign. So that will be negative 2. So our a is negative 2. Okay, so all we need to do now is to do the substitution process, or what we call as evaluating polynomials. We assume or we assign negative 2 as the value of x. Okay, or we call it a root. Okay, so this is our polynomial. Okay, this is how we denote a polynomial, a function. Okay, so p of x and then the polynomial. So all we need to do is to replace the letter x with negative 2 and then enclose the negative 2 with a parenthesis. Okay, so let's do that. Okay. So replace x with negative 2. So x here, negative 2, enclose it with parenthesis. X in the second term, enclose with parenthesis, negative 2. And then x in the third term will be negative 2. Now we are going to compute for the first term. What did you notice? Yes, we have a negative base. There are two things that can happen, okay, for a number exponential form with a negative base. We can have a positive answer, a positive standard form, or a negative standard form. So if the exponent is an odd exponent, like this one, so odd numbers are 1, 3, 5, 7, 9. Okay, so if the exponent is an odd exponent, then the answer is negative. The standard form is negative. Okay, so again, let's write that here. So negative 2, it's a negative base raised with an odd exponent. So it's odd exponent, so the answer is negative. And then how much is 2 cubed? 2 times 2 times 2 is 8. So negative 2 cubed is 8. Okay, so that would be for our first term. So that would be negative 8. Now for the second term. So copy 5, and how much is negative 2 squared? So again, we have a negative base raised to an exponent that is even. Then the answer will be positive. And then how much is 2 squared? It's 4. So negative 2 squared is positive 4. So we are going to replace negative 2 squared with positive 4. And then let's compute for the third term. So we have a variable k. It's a positive k multiplied by a negative 2. So let's review. If we are multiplying a positive factor with a negative factor, the answer is negative. So, and then if we have a number multiplied by a letter, we just have to copy the number and then write the letter beside it. Okay, so k times negative 2 is negative 2k. Okay, now you might have noticed that we have a positive and a negative next to each other in an expression. Okay, then we can just remove the positive sign and then have and keep the negative sign. So if we have negative 2k here, it means that the sign of the third term is negative. The third term is negative 2k. Okay, so you can practice saying negative 2k instead of minus 2k. Okay. Now we are ready to evaluate further. So we have negative 8 as the first term. 5 times 4 is 20. Okay. Now for the final answer, we can practice putting marking for similar terms, like the constant terms. So, negative 8 is a constant term, positive 20 is a constant term, and positive 1 is a constant term. So, we have 3 constant terms. But then, or constant terms. But then, in our standard form, we just need to have 1 constant term. So, all we need to do is to combine the 3 constant terms by adding. So, negative 8, positive 20. So, let's review your operations on integers. So, those are unlike terms. Okay, so we are going to subtract the numbers and then copy the sign of the positive of the bigger number. So, let's subtract 20 and 8. Okay, so take away 8 from 20. That's 12. And what is the sign of the bigger number? So, 20 being the bigger number, it's positive. So, negative 8, positive 20 is positive 12. Then positive 12, positive 1 is positive 13. Okay. So, again, negative 8, positive 20, positive 12, then positive 12, positive 1 is positive 13. So the remainder now for the first polynomial is 13 minus 2k. And now for the second polynomial. So the same drill. Our a is negative 2. So we are going to replace the letters x, or the letter x, with negative 2. So let's do that. So just copy the polynomial here and then replace x with negative 2. So the base here for the first term is negative 2 and then 4 times negative 2. Okay, now let's do the third line. So negative 2 squared. So we have a negative base, even exponent. So the answer is positive. And how much is 2 squared? It's 4. So we have positive 4. Then for the second term, positive 4 times negative 2, it's a negative 8. So when multiplying a positive factor with a negative factor, the product is negative. Okay. And then combine positive 4, negative 8, that would be negative 4 indeed. Okay, so the remainder for the second polynomial is negative 4, negative k. Alright, so we are now going to find the value of k. Okay. So let's proceed. So it says, the problem says here that the remainder of the first polynomial is equal to the remainder of the second polynomial. So we are just going to equate the remainders. So we have 13 minus 2k equals negative 4, negative k. And then we are going to isolate the terms with the variable k. So we're going to do transposing. So copy negative 2k in the left side and then transfer negative k from right side to left side of the equation. So we have positive k. And then copy negative 4 at the right side and then transpose positive 13 from left to right. Okay. Then the sign of 13 will change from positive 13 to negative 13. Okay, that's what happens when we transpose a term from left to right or right to left. So the sign will change. And now negative 2k, positive k is negative k. And then negative 4, negative 13 is negative 17. And we always get a positive variable. So negate both sides. So we have k equals 17. And then in the next video lesson, I'm going to show you how to check your answer using GeoGebra.